Today, we're going to hear about some case studies of commercial projects where we turn the client's subterranean dreams into reality. And first up, he's flown in from Ireland this morning. It's Eoin O'Meara from John Sisk. Over to you.
Thanks very much, Steve. Hello, everyone. So I'm going to take a quick run through into a brief introduction of John Sisk and Son, talk about Project Kells, which is a Dublin city centre development we're currently working on. It was a big demolition job, so I'll touch on that, talk about the basement construction, and finish up then on the logistics planning, which is the biggest challenge for us on the job. I have two videos which take about 8 minutes, so it doesn't be long for the slides. So I may fly through some of them, but if anyone has any questions after or like to discuss it further, I'd be delighted to talk through it. John Sisk, so it's a 160-year-old family business set up they're the biggest construction company in Ireland, set up in the UK in 1984, and have expanded since into Europe. That's Nina Church in County Tipperary. It's actually where I got married, and I remember during the ceremony looking up and thinking, how did they build this building? Probably not what I should have been doing at the time, but it was Sisk's first project in the 1800s that they built, and then have since developed from that and building the likes of the Aviva Stadium or Croke Park redevelopment in Dublin and convention centres. So Project Kells, the bottom left is how we obtained the site. It was existing structures ranging in height from 5 to 8 stories over the full perimeter. The middle picture probably gives a better indication of the footprint of the job. To the right is Grafton Street, so the main pedestrian street in Dublin City. To the south is Trinity College, and the site is bounded on the south and the east by the Lewis light rail, which is an overhead electrified light rail system. So we didn't really have anywhere around the site for offloading or deliveries or laydown. The basement was for the full site perimeter. The bottom right is what we're currently working towards the handover for Christmas next year. We put a lot of work into this at bid stage and came up with the key challenges in the projects and strategies around how we're going to attack them challenges. I won't be able to talk through them all, but a key one, say, for managed stakeholders, we came up with, say, different communication strategies, how we're going to target them stakeholders, group them into different importance, and I'd say we delivered 20 to 30 different presentations before we even set foot on the ground. The demolition works, we did a top-down demolition with 9 to 12 ton excavators munching the slab up on the slab. There's a few unique aspects. There was a live fire escape, so Lily Bordello's is a high-end nightclub in the middle of Dublin City. Their fire escape was right through the centre of the site that we had to maintain live 24/7. 9 metres across the road, there was a protected structure, St. Patrick's Well, where vibration control, crack monitoring, water levels was key. And then we had a 1600s building, Dingle Whiskey, that our demolition was tied up against. But probably the trickiest part was this corner where Dublin City Council advised us it was the second busiest pedestrian corner in Dublin outside the top of Grafton Street. The existing footpath was at capacity, so we couldn't close that or encroach on that at any time. So we ended up diverting the pedestrians in under the structure as we're demolishing above, with crash decks and noise reduction measures above the tunnel. With a lot of stakeholders to take through this, so the likes of the Lewis, the owners of the Light Rail Transport Infrastructure Ireland and DCC. And the best way we did that was developing up in BIM and doing a sequence and talking them through it. And we got very good positive feedback from them. The likes of the Transdev, the Lewis operator, wanted perspex screens instead of full hoarding so their drivers could see through. Dublin City Council came back and asked the perspex to be returned internally so pedestrians could see out and see the tram. So it worked very well for us, and it's something we did throughout the job then was BIM it up, do it in 4D, run it through the stakeholders and internally tweak it before we went to deliver it on the ground. And I have a quick video of 2 examples of that. basement construction. We had existing rock level information which showed a gradual fall in the rock level across the site. We had a lot of conversations with the pile designer, Bern Luby, and decided to supplement the existing information with more boreholes. So you can see on the right, we brought a borehole rig in as the building was being demolished above, breaking out holes in the slab to be able to supplement that information. And we got surprising results on our end. We found that there was actually a fault line, which Bern Luby think, or else a depression through the middle of the site with the rock, where the rock level varied about 5 meters vertical over about an 8 meter horizontal. And it allowed us then to change the foundation design. Originally, the bottom right there is a section view of the original concept was to dig below the pads down to rock, lean mix back up and do your pads. But we changed that to having a partially piled foundation design as the top right there, partially excavate below to the rock where there's 1.5 meters, less than 1.5 meters to dig, or actually some of the pads were actually on rock. And having that exact information gave us a lot of confidence into the Sisk and pile wall design, which we amended from an ODEX to a CFA concept, which I'll discuss in a minute. The transition from the demolition to the piling, we wanted a very smooth transition, and we did up a sequence of how we were going to achieve that. The piles were right up against the perimeter. We were keeping the existing retaining wall. So we propped the existing wall, created the soft spot in a kind of hit and miss fashion, like underpinning, completed the piles, cast the cap and beam, demolished the existing basement slab, and then installed some horizontal props. We didn't want any raking props down into the foundation that could impact the basement program. And this was a bit of a sequence. It's a very simplified sequence, but we worked from start on site back to designing the cap and beam, designing the piles, designing the anchors, designing the Sisk and piles. There was a lot of information we needed at the very start of the job, likes of the penetrations through the cap and beam, where the ESB were coming in, and we just wanted to demonstrate in a timeline to the client of why we needed that information early. The pile itself, so it was a 360 meter Sisk and pile wall down to a depth of about 15 meters. Originally, we had planned for ODEX, but we were concerned both vibration transfer and our program. Knowing the exact rock levels, Bern Luby developed a sequence based on CFA piling, which, although we couldn't achieve the depths, the ODEX, when the rigs got to site, we did a lot of probing, and where we couldn't achieve the depths, the hard piles were supplemented with a shear key, which was a 75mm steel bar that went down through the toe of the pile and 3.5 meters down into the rock. The bottom left was our original shoring solution, which was all ground force hydraulic props. But through dialogue with DCC and the stakeholders, we got approval for putting the glass fibre reinforced polymer anchors down at 45-degree angles below that Lewis line, that once de-stressed could be dug through at a later date if required. And it really opened up the site to us and gave us a lot more room. The bolt dig, the main aspect of the bolt dig was just the sequencing with the other aspects of the job that were happening, but also the monitoring. With all the sensitive receivers around the site, we had the inclinometers in the piles, but we had a lot of additional monitoring actually happen at the same time. The top there is the Lewis monitoring, so we're scanning that 24/7. On the second image on the right there in the middle is actually every point on the line and where it is relative to a trigger level, which was 4 millimeters. The middle there was the ground force props, so we actually did load monitoring on them props. We picked 4 props, 1 in each corner. You can see the initial stress here on the left, and then the changes there, just the daily variations with the heat during the day and the night. And having that information actually allowed our temporary works designers to do an assessment and remove some of them props early, which greatly helped our program. Aside from that, there was the noise, vibration, the building movement, so like that 1600s building was being scanned as well, plus the water levels. The wells both inside and outside the site were constantly monitored, and all this information was available on our phone at any time, which is great for the stakeholders. We could go and show them we're tracking this 24/7. On the train in the morning, if I was very bored, I'd go through each of these and have a check through where we're at. Logistics planning was the biggest challenge for us. And how we came over that was building temporary platforms, so 2 temporary platforms in on the site. They were quite considerable platforms, so they could take, say, a 120-ton mobile crane or 2 concrete trucks with a pump. So the left there is the planned, and you can see the right there, the actual during a concrete pour. They were also quite unique in that we worked with the permanent works designer and actually cast a permanent ground floor slab on top of the temporary steel, which was, it sounds probably simplified there, but there was a lot of work in coordinating of advancing that design early, but also knitting all the permanent works later on up underneath that slab. And there's a video in a few minutes that'll probably explain that a bit better. The construction of them platforms, so it was UCs plunged down through the piles during the piling works with a steel platform built above after, and then the slab cast on top. And then COVID hit in the middle of this, so our supply chain really worked with us. The likes of Ground Force, they delivered all the props from the UK over to Ireland in case of any customs delays with COVID or with Brexit. We migrated a lot of our hard copies of our site documentation onto digital, which is something we probably could have done pre-COVID, but COVID pushed it to us. So the likes of this barcode here is the common lift schedule. So when guys are down on site, they can scan that, and you can see they might be about to lift some steel. They can scan that, hit the structural steel, and see the exact rigging diagrams on their phone of what that should be. Sisk were actually fairly good as well of keeping us all engaged and engaged during the time at home. We were shut down for one 8-week period and another 17-week period. And I think that is a world record at the top. It's 58 Irish builders signed up to online Pilates classes. But I don't have any of the images to prove that. It's just signed up. I don't know if they did it or not. And then key aspects for us that led to the successful delivery, the pre-planning that went into the job right from the tender stage. And the client actually said one of the reasons they went with us was because we came with a solutions-based bid. We had identified all the challenges and a solution to each one of them. There's the stakeholders, engaging with them early, delivering them detailed presentations, and especially in 4D where they can properly see the concept of what's happening on the job as opposed to some slides with technical details. The influence in design, the design team working with us at the right time, so the likes of changing the foundation design, changing items to precast, and also the platforms of casting the permanent slab. And that wouldn't have been possible with the strong collaboration with the wider team. The photo on the right is a hell and back that us, the design team, the client all did before the job, which was an 8-kilometre run, basically pulling ourselves through mud pits and over obstacles, and it really set the tone for the job. The end result was that the 8-week shutdown we had, were able to absorb all that time in our programme without any EOT, and also the significant risks that could have gone wrong were all mitigated. And now there's a video kind of explaining the job.
Project Kells is a mixed development of retail and commercial in Dublin city centre, based on the corner of Dawson Street and Nassau Street. The 7-storey building with 2 levels of basement. The logistics and the surrounding environment has been the biggest consideration in relation to the constructability and the planning of the project.
We first started a small dig here underneath the gantry here, just so the other companies could work away on this end of it. We came back around then to this side here, and we dug away around just to get the basis for the crane ready. And as we came around then, we had a ramp built up out onto Dawson Street there.
Like every other city centre job, it has its challenges in terms of logistics. On this site, access and egress was one of the earliest concerns that Sisk had, and behind us you can see some of the platforms that were constructed early in conjunction with the primary frame, piling contractors and the engineers to allow access to serve the project.
It's a double basement. It's about 8.5 metres to floor level with to formation level you go down 9.5, 10 metres. The basement construction is what we call a white tank system. The reinforcement is designed to be a water-retaining structure. But in addition to that, we have a cavity wall system inside the basement, so we've got double protection. This is a temporary platform. The Sisk had the idea that if we could incorporate it into permanent works, it would save on programme, costs and so on, which was a very innovative idea. So with the client's consent, we incorporated the temporary platform into permanent structure.
So our involvement in this project was from the Technical Office, which is an internal design consultancy that we specialise in temporary works design and other engineering disciplines. So the bid team approached us during the tender stage to look for solutions on how to build a basement within a basement, and also to help out with the logistics. So how do we provide space within the site to get the deliveries into site and get them mucked out? So we worked very closely with the bid team and with the designers, permanent works designers, to design the temporary gantries.
The key to this project, from my point of view, is the logistics of the project and the pre-planning that went into that to allow the project to flow. From the start, we had to plan the bulk dig, starting in the right location of the site, working our way across the site. This allowed us then to erect the two tower cranes in a proper sequence, not interfering with the bulk dig and not interfering with the follow-on tray, which is the concrete frame.
In fairness to Sisk, they took us on board 6 months before we actually came to site. And in fairness to their management team and our management team, we've sat down numerous times before we even came to site. Just especially with the challenges with the basement and so forth, and the logistics of the site, getting in and out. So there was a lot of collaboration between both parties.
The constructability and sequencing of the project was at the heart of the platform design. And this started right back at piling stage, where the temporary UCs needed to support the platform were incorporated by the pile designer into the permanent pile design. The permanent works engineer Maloney Miller brought this forward by advancing, tweaking and adjusting the frame design to suit the temporary works requirements in strong collaboration with the Sisk temporary works engineers. The steel fabricator, they then tweaked and put tolerance into the connection designs, allowing the steel to be fabricated prior to final site surveys. And finally, the frame contractor wraps, they produced a false work design without any propping needed below the platform. This enabled the bulk dig, blinding and crane based works below to continue in tandem with the platform works above. The end result was that the key site activities could progress in parallel with construction of the platforms, resulting in no impact to the programme.
BIM and digital project delivery has been implemented on Kells in several ways. We've used it for coordination and clash detection, construction methodology, logistics planning and 4D sequencing.
I think the whole team has worked tirelessly. I think in January, when we started looking at this phase of the project, we didn't know what was ahead of us. But certainly the team, Sisk, Maloney Miller, Henry Lyons and EDP and Lafferty project managers have all worked tirelessly together to get the project to this stage.
The great progress would not have been possible without the great collaborative approach by the design team, the Sisk technical office, our supply chain partners and our own strong site team. We're now in a great position to successfully complete the basement works to push on to finish the superstructure on programme. We would really like to thank everybody for their efforts to date.
Thanks very much.